Okay, this video is about the rate determining step and how we can work that out from the rate equation. So first thing we need to do then is work out the rate equation. So I'm using the initial rate method here. I've got a table. So if I want to work out the order of reaction with respect to the concentration of NO, I would look here at where hydrogen concentration is constant. So experiments 1 and 3. And I can see here that the NO going from experiment 1 to 3 has been times by 3, and the rate for the same experiments has gone from here 0.02 to 0.18, so that's actually been times by 9. So this is trebled, this has been times by 9, so it's not first order, it'll be second order because 3 squared is 9. Then if I want to know for the order of reaction with respect to hydrogen, I look at experiments 1 and 2, NO is constant, this has been times by 3, this has been times by 3, the rate has, so 3 to the power 1 equals 3, so it's first order with respect to hydrogen, so our rate equation can be given as such. Okay, so that's our rate equation. So we want to find the rate determining step, but what is the rate determining step? It's the slowest step. The slowest step determines the rate of the whole reaction. So if we can work out what the slowest step is, we can work out a lot about the kinetics, about the mechanism of the reaction. So because this is the order 2, there must be 2 NOs in the rate determining step. Okay? Because it's second order. So because it's second order, there are 2 NOs in the rate determining step, and they must be reacting with 1 hydrogen, because it's first order. We don't write 1, but it's first order. There must be just 1 hydrogen reacting with them. So that's how we get the reactants of the rate determining step. Okay, it's what's in the rate equation, and the coefficients is the order that they are in the rate equation. So if we're looking at what we're making here, we've been told we made H2O. In this case, give us some information, so we can work out what's left. It must be N2O, because we take H2O away from these reactants, we're left with N2O. Now, there's no N2O in the overall equation. It's the overall equation up here. N2O does not feature. So when we combine these two steps here, if this is the rate determining step, this is the fast step that doesn't determine the rate. You combine these two steps, it must make the overall equation. So N2O, if it's made, it must also be used up in the second equation, okay, in the fast step. And it's an intermediate. It's been made in the reaction, but then it's used up. So what does it react with? Well, if we look, we've used 1 hydrogen here in the rate determining step, but in the overall equation, there's 2 hydrogens. We've used both the NOs in the rate determining step, but only 1 of the hydrogens. So the second hydrogen must react in the fast step and react with the intermediate, and then we make these products here. So overall, we've got 2 lots of H2 reacting with 2 NOs. That cancels out, that cancels out. We make 2 waters and 1 N2, and that's exactly what we've got along the top there.